Hey everybody, Jeff Oriema here. Friends don't let friends roll their own GraphQL client. I mean that pretty broadly. Web, iOS, Android. If GraphQL is a meaningful part of your application architecture, I think you should have a really, really good reason before deciding to build the client layer yourself. Now, I get why teams talk themselves into doing stuff like this, and it can seem reasonable. One of the biggest stories people tell themselves has to do with using the stuff that's already included in their platform. On the web, you have fetch, right? In iOS, you have URL session and codable. Android has perfectly good networking and serialization libraries. Making an HTTP request and turning some JSON into objects is not hard. You can get something working pretty quickly. Send an operation, get JSON back, decode it, pipe it into your hooks or whatever abstraction your application already uses. And at that point, a GraphQL client can look like a lot of machinery to include for something your platform already knows how to do. And that's both completely fair and also misses about like 90% of the value of a GraphQL client. Another objection you'll usually hear is around bundle size or binary size, or just dependency aversion in general. I can't say that's without merit either. Dependencies have a cost. On the web in particular, people look at something like Apollo Client and ask why they should ship all of that JavaScript when a much smaller abstraction can make the same request. But a lot of those concerns are overblown. Apollo Client 4, for example, is substantially smaller than Apollo Client 3, so the initial tax is not necessarily what people remember or assume it being. But beyond even that specific tool, I think bundle phobia or binary size aversion tends to focus attention on the easiest cost to measure. You might save some bytes up front by avoiding a GraphQL client. But what happens over the rest of the application session? Well, that's where things get a little more interesting. A normalized cache can recognize that the user object that you fetched on one screen is the same user you fetched somewhere else. It can reuse data you already have. It consolidates multiple representations of the same entity into the same cache. It can let a mutation update something once and have that change propagate wherever that entity appears. Well, now that cost profile gets a lot more nuanced. Maybe you saved some bytes up front by rolling a bare bones GraphQL client. But how many redundant network requests are you making as a result? How much duplicate JSON are you downloading? And how much code are you writing to keep all of those copies synchronized? A mutation comes back with a new name. One screen updates. Another screen has the old name, so you add some code to fix that. Then somebody wants an optimistic update. Then two requests overlap and the older one finishes second. Then you need pagination, then cache eviction, then request deduplication, and then some piece of the UI needs to react when an entity changes somewhere else in the application. None of those problems is especially exotic or unprecedented, and that's part of the trap. You solve them one at a time because each individual problem looks manageable. Then a year later, your team has this internal data layer that has caching, identity, observers, pagination logic, request coordination, retry behavior, mutation handling, and congratulations. You've now rolled your own GraphQL client and your team are all now part-time GraphQL tooling maintainers without the open source glory. One of the places where I get much less sympathetic is in code generation. One of the strongest reasons to use GraphQL from a typed language is that the API already gives you a type system, and your operation tells you the exact shape of the data that you're asking for. If I write a query that selects a user's ID, name, and profile photo, there is no reason a Swift engineer should then sit down and manually write another description of that result as a bunch of codable structs. You already wrote the types. You wrote them in GraphQL. Apollo iOS can generate Swift models from your schema and operations. Apollo Kotlin can do the same thing with Kotlin types. GraphQL Code Generator can do the same thing for TypeScript and other languages in other environments. If the schema changes and a human being has to remember which native models need to change with it, you've created a synchronization problem for yourself that the compiler could have handled. And mobile makes this especially important because you're shipping compiled clients that may live in the wild for months. The relationship between the schema, the operation, and the generated model is part of your contract with the server. I would much rather have tooling own that relationship than somebody maintaining it manually from my team when they should be focusing on the product. Then there's the GraphQL specific behavior that starts accumulating. Pagination is a great example because everybody needs it eventually, and it sounds simple right up until you actually have to integrate it with the rest of the application. You fetch the first page and the next page. Those results need to become one logical list. You have cursors, arguments, potential duplicates, right? Entities that may exist elsewhere in the cache. Refetches need to replace some data without blowing away everything else. And maybe multiple screens are observing the same connection in the case of a data-rich application. Now, you can absolutely build all of that yourself. But now you are very clearly writing GraphQL infrastructure, and pagination is just the beginning. Think about all the essential parts of a GraphQL deployment in 2026. Persistent operations, subscriptions, partial results, incremental delivery with defer and stream, different transport behavior, and maybe some future addition to the spec that nobody on your product team was particularly excited to become an expert in. There are also pieces of GraphQL syntax that a very thin networking layer can initially ignore, like aliases, like fragments, directives, and nullability rules. You can send those things over HTTP without really understanding them or handling them. But once your client starts reasoning about operations, generating types, caching fields, merging results, transforming documents, the semantics of GraphQL become your problem too. And I do promise you, you and your coding agents are going to miss some of them. This is one of the less glamorous benefits of using a mature GraphQL client. Other people have already spent years finding the weird cases. You also inherit an ecosystem around that client, like dev tools, testing infrastructure, framework integrations, observability hooks, APM hooks, cache inspection, persistent operation support, and documentation. None of this means you have to install a heavyweight GraphQL client every time you encounter a GraphQL endpoint. If you have a script making 3 queries, whatever, make the requests. If GraphQL is a tiny, deliberately constrained piece of your application, and you know you don't need caching or code gen or any of those other things, maybe a full client genuinely is unnecessary. But if you're building an application where GraphQL is actually part of the architecture, I would be very suspicious of the argument that your needs are too simple for a real GraphQL client. Friends don't let friends roll their own GraphQL client. Let me know in the comments if you or someone you know is maintaining their own GraphQL client, though. What has your experience been? And don't forget to subscribe for more software development videos. That's it for now. See you next time.